Today we'll be taking a look at improper integrals. An improper integral is an integral in which one of the bounds is something irregular. For example, the integral from 1 to infinity of 1 over x dx is an improper integral because infinity as our upper bound is not something we like to see. Well, let's go ahead and evaluate this integral. The first thing we can do, because we don't like seeing infinity as one of the bounds of our integral, we can replace the upper bound with a variable and set the limit of the variable to infinity. So we would do this by writing the limit of a variable t approaching infinity of the integral from 1 to t of 1 over x dx. So now let's move on. In each step, we have to keep our limit because we do not want to have infinity as the upper bound of our integral. So our next step, we would get ln of x from the bounds of 1 to t, and then we would get the limit of t approaching infinity of ln of t minus the ln of 1, which is equal to the ln of infinity minus the ln of 1. And this gives us a final answer of infinity, which is not what we want. Anytime we get a result from an integral that is not a finite number, we can say our integral is divergent. There's two possible scenarios when evaluating an improper integral. Your integral can either be divergent, meaning your answer is not bounded, or it can be convergent, meaning your integral returns a finite number. Let's move on to another example. What's the integral from 1 to infinity of 1 over x squared dx? Let's solve with the same steps. First, we can create a variable and set its limit to infinity. So the limit of t approaching infinity of the integral from 1 to t of 1 over x squared dx. Our next step would give us the limit of t approaching infinity of -1 over x evaluated from 1 to t. And so now we get the limit of t approaching infinity of -1 over t minus -1 over 1. And plugging in t as infinity, we get -1 over infinity minus -1. And so our final answer gives us an answer of 1 because -1 over infinity is just 0. And so that means that this integral is convergent. We're able to get a finite number by evaluating the integral. And those are the two scenarios that you've seen of what can happen when you evaluate an improper integral. These terms start to make more sense when you're working with an infinite series, but for now it's still important to understand how and what are the steps to evaluate an improper integral. Thank you for watching this video. If you have any questions or any other calculus concepts you'd like me to discuss, just leave a comment down below. Thank you for watching this video. I'll see you in the next one.